All right, Robin, ready when you are.
Great. Thank you so much, Ben. And thank you, everyone, for joining us this afternoon. Should be afternoon for everyone. Yeah. We're excited to be here to answer any questions y'all might have. So welcome to our very first pre-proposal Q&A session. This is for our Ideas Lab on radiation quality, dose rate, model development, and translation. So could I have the next slide, please? So for those of you who don't know us, although I think many of you do, we are the Space Radiation Element. We are part of the Human Research Program at NASA. And the goal of the Space Radiation Element is to ensure that crew members can safely live and work in space without exceeding our acceptable radiation health risks. And so you know who the team is. I am Robin Elgart. I am the Space Radiation Element Scientist. With me today, we have Janice Zawoski, the Deputy Element Scientist, Brock Sykes, who is our Cancer Discipline Lead, and JP Saha, who is our Degenerative Tissues Discipline Lead. We also have a CNS Discipline Lead, Greg Nelson, who couldn't join us today. We also have Manish Arya from the Program Office. And on the management side of the house, we have Jason Weeks, Nick Meyer, and Lisa Stevenson. These are the people who really keep our world spinning for us. So just a brief introduction to the element for those of y'all who don't know us, and this is what we actually look like. Hopefully one of these days we will all be able to see each other in person. So next slide, please. So to give you an idea of where we're headed, the timelines of these things always tend to change, especially when there are changes in administration. But as of now, we are headed for boots on the moon by 2024. This is through our Artemis missions. And next slide, please. And from the surface of the moon, we, of course, are headed towards Mars. And getting us there, we have a variety of different missions that we are planning for in the future. And this is really where we have unanswered questions, especially for space radiation, of how we're going to characterize and mitigate some of our risks for space radiation. So next slide, please. So one of the things that we're doing is putting forward a sort of novel thing for NASA, which is the Ideas Lab concept, and I will pass it over to JZ, Janice, to carry on from here.
Thanks, Robin. So for lack of a better term, we are calling this Ideas Lab, which we took from the NIH. And what we are planning to do is we will eventually have a workshop. We will cover the current state of knowledge. We'll also cover the selected panelists' expertise and background. And then we'll dive into the gaps and the gaps of knowledge and areas of interest we are interested in, which in this case, we are interested in dose rate and radiation quality, which I'll talk more later on. And then at the end of the workshop, we will then dive into strategic and experimental approach. To try to become a part of this workshop, what we are requiring people to do is to do a self-nomination, which is due on December 11th. And it consists of a 2-page either CV or NIH biosketch. And then also included in that is a 4,000-character statement. And in this statement, we want you to include your capabilities, your approach, and also gaps or additional areas of interest that maybe we have missed. And we also want to know how you are aligned with the space radiation strategic needs. And hopefully we'll get these back December 11th. We want to have notifications out to who we select in January. And then we, again, as I had mentioned, we are planning on a workshop in late March. We are actually probably going to spread the workshop over probably about 2 weeks, just because we're cognizant of people's times, and we know it being virtual that it is going to be hard to schedule a large amount of time for people. And then from there, we will have strategic and experimental approaches. These studies then will be peer reviewed. And then the ones that score high and are aligned with our strategic need, we will then fund those. Note this will be a direct collaboration with the Space Radiation Element, so it will be more of a directed study than the usual grant. Next slide, please. And so in the space radiation element, we really have 3 areas of research. Our main and primary area of research is radiation-induced carcinogenesis. And then we also inform the radiation-centric studies of cardiovascular and immune, as well as central nervous system. For this RFN, we are interested in dose and dose rate effectiveness factor, radiation quality, also translation, and biomarkers. Next slide, please. And so we are interested in an interdisciplinary team. I'm not going to read through all these, but it really spans from radiation biology to biostatistics. And note that this call is open to not just academic institutes, but also commercial entities, international organizations, and even government agencies. And also, we are very interested, and we want to include early career investigators as well as new investigators not previously funded to space radiation. So please, definitely, if you're an early career investigator or you haven't been funded by us, we really encourage you to apply. Next slide. And so I will pass it off to Brock Sykes to dive into our areas of focus for the Ideas Lab. Thank you.
All right, thank you, Janice. Can somebody confirm that you can hear me, please?
Yes, sir.
Okay. All right, so we understand that this is sort of a nebulous concept of what we're trying to put together here. So what we wanted to do and what I want to do is give y'all an idea of the types of areas we want to focus in and some of the questions that we're thinking about internally that are really going to help us meet our strategic needs moving forward as a program. Well, this is what we're thinking right now. If you have other good ideas that you feel like you want to pass along to us as part of this process, we're glad to hear it. That's why we wanted to work collaboratively and not necessarily just in a grant-based format, okay? So really, this Ideas Lab we propose that it should include 5 areas of focus. The first is addressing unanswered questions with regard to space radiation quality, understanding the low dose rate effects for heavy ions, what those are, and what investigations we need to do to understand those better, okay? We really want to understand newer approaches and new technologies, how we can leverage those to look at human model development. We want to look at the translatability of existing animal data sets into human risk models. And finally, we're interested in looking at biomarkers that can be utilized as surrogate markers or endpoints for early detection or indicators of cancer, CNS, immune, or cardiovascular degenerative effects. Okay, when we say surrogate markers, things that we could use, for example, to accelerate our research, so we're not necessarily waiting 3 or 4 years for an animal to get a tumor. Next slide, please, Ben. All right, and within each of those focus areas, we've proposed some questions that we really want to start people thinking about to sort of frame, or to start to frame the discussion we want to have as part of the workshop itself. So with regard to radiation quality, we really are looking at 3 areas. The first question is, what gaps remain in our data of radiation quality, specifically regarding the simulation of the space radiation environment? Okay, what's out there? How can we incorporate rodent data using single ions, using the GCR simulator, etc. Okay. The second question we want to ask is, we recognize that RBE is kind of the gold standard for how we measure radiation quality, but we also understand that there's other approaches to understanding quality differences out in the ether as well. So the next question we want to ask is RBE an effective metric to capture radiation quality effects? And if not, what alternatives exist, or what alternatives can be used in conjunction with RBE to really get a more comprehensive picture of what we're looking at? And then finally, how should protocols at NSRL be modified and standardized to close the radiation quality gap, Cancer 201? Okay, specifically, over the years, people have done many different ions. We now have the GCR simulator. How, as an element, can we direct our researchers to standardize what we're doing so we're getting a more comprehensive picture of what's going on in the space radiation environment? Some questions we want to specifically think about. Are single ion exposures sufficient to model GCR? Okay. Are protracted hyperfractionated studies with ions necessary? Okay. And what should the role of the GCR simulator be going forward? Okay. We understand that the GCR sim is a fantastic tool, and there's been a lot of blood, sweat, and tears into developing it. And we want to use it to its absolute best potential to answer the questions we have in our gaps. Next slide, please, Ben. Of course, our next big focus area is low dose rate effects of ions. Okay, specifically, we want to address how we answer these questions and really get at what types of models we need to utilize to answer these questions. First and foremost is, we are at a ground-based accelerator facility, so we want to ask the question of whether or not that does protracted hyperfractionation of ion exposures model the dose rates in deep space environment effectively. Okay. We know that low dose rates are sparing for normal tissues and for low LET radiation, specifically photons. Okay. But we do want to ask the question, are low dose rates sparing for light, medium, heavy ion exposures as well? And how should that be incorporated into our risk models? Okay, and finally, we want to ask the question of whether or not neutron exposures are sufficient to model the dose rates observed with HZE ions in space, and specifically what data would we need to be generated to validate that comparison. Okay, next slide. We're also very interested in bringing in some of the newer technologies available or that have been developed over the last decade to really accelerate our research and get a more comprehensive understanding. So the basic question we want to ask is what non-rodent and non-2D cell culture models should be leveraged to address questions regarding quality and dose rate effects. Okay. Some of the ideas we've had out there, but we're certainly not limited to these, are how do we leverage iPSC induced pluripotent stem cell technology? How can we incorporate tissue on a chip? What about 3D organoids or 3D bioprinted tissues? Again, these are some of the things we've been thinking about internally, but if you have other ideas, we would love to hear them. And second, we understand that doing this research with new equipment and things like that does require additional capabilities. So we want to ask the question, what capabilities or infrastructure would need to be put into place at BNL to leverage these technologies? Okay, next slide, please. All right, and that gets us to this translatability of existing animal data. We understand that most of the data sets we have are in rodents, okay? But some of the questions we want to ask are, first and foremost, are susceptibility rodent models, specifically inbred strains or gems, appropriate representations for a genetically diverse astronaut population? Okay. Second, what data needs to be generated so that appropriate scaling factors can be incorporated into risk models from rodent data if we do determine that it's usable and translatable to humans? And what additional experiments need to be conducted to increase the fidelity of rodent model translatability? Again, we're thinking long-term. We're thinking, how do we get from rodents to humans, and are rodents an appropriate model to mimic human exposure to space radiation? Next slide, please. And finally, that gets us to surrogate biomarkers. So what we're really concerned about is understanding what early detectable surrogate biomarkers for carcinogenesis, cardiovascular disease, and CNS defects are available to leverage to accelerate space radiation research. Again, we understand that we're talking about late effects when we're talking about things like cancer, CVD, and CNS. So are there things that we can look at to get a clearer picture early on that's going to predict what we see later on down the road with late effects? Okay, and again, what studies would need to be conducted to validate those biomarkers for translational space radiation research? Okay, next slide. So here we have some useful links. Again, it's our evidence book, the Human Research Roadmap, the task book, all this here. So please feel free to check these out, as these are great resources to get more information about NASA and specifically the space radiation element. Okay, next slide, Ben. And with that, that is the end of our presentation, and we want to go ahead and open up the floor for questions. So I will let Robin take back over.
All right, thanks, Brock. So Ben, how are we working the Q&A part of this?
Oh, sorry. Usually what we'll do is we'll take questions in chat and you all can answer them in the audio. If you prefer, I can enable microphones since we don't have a huge crowd today.
Either one works for me. Let's go with the chat and see if we have any questions. So
okay, we'll stick with chat then.
Feel free to put your questions in the chat. Jeremy Polf yes, these slides will be, this entire recording actually will be shared on the Nspire site. Is that correct, Ben?
Put a link to it on the Inspire site. Usually we share the recordings on a YouTube channel that we have.
Perfect. So yes. I see a couple people typing. Yep, thank you. BioSketch also limited to 2 pages. Yes. Yes, you have absolutely have that correct, John. So the question is, for the application, is the BioSketch also limited to 2 pages? And in addition to that, we have 4,000 characters to pitch a project. Is that correct? Yes. So BioSketch is limited to 2 pages. We're not particularly interested in, you know, everything that you've ever done in your entire life. Really, we want a more focused BioSketch, so we can understand how you see your background really plays into this approach. And then for your pitch, it is limited because of the Nspire site to 4,000 characters. So be cognizant of that. Question from Jeremy Polf. BioSketch is NIH format or NASA format. The format is really not important. We just figured a lot of people already had their NIH BioSketch available, so you could feel free to use that. But if you have a different format that you have for your BioSketch, feel free to use that.
But I'm going to jump in real quick and just add that what we really want these nominations to be is we want to see a 50,000 foot above view of what your idea is and just really get a feel for your expertise, your capabilities, and what your ideas may be. There's going to be a process that's going to happen before we actually do the workshop. So just know that you're going to be working with us and consider these an intent to participate. That's the way we've been kind of.
These nominations also these are considered proprietary. They won't be shared in any way as well. I want to make sure that's clear. Colin Cruz, the research goals here are primarily aimed at understanding human biology consequences of radiation, correct? Yes, you absolutely have that correct. And then Joseph Wu, how is this RFA different from this series of letters and numbers? I'm assuming that is the countermeasure RFI. If I don't have that correct, okay, cool. Thank you, Ben. I can't keep all these alphanumeric things straight in my head. And so the this RFN RFN is particularly focused on these outstanding questions of dose rate and radiation quality, whereas our other RFN is really about setting up the infrastructure and capability to do high throughput screening of countermeasures to help mitigate those radiation effects. Brock, do you want to jump in there if you have anything else to add with that?
Yeah, so this is really aimed more at basic research, whereas the other RFI or the other call for nominations was actually closed on this previous Monday, I believe, is more aimed at specifically identifying countermeasures and, again, establishing the infrastructure and capabilities to accomplish that goal. So these are, just to spell it out for you, these are going to be 2 different funding opportunities, and this one's going to be aimed more at research rather than countermeasure discovery.
All right, and then Dr. Chikana Pashut. Should the 4,000 character statement be focused on pitching a specific project or describing our qualifications? I think Brock sort of previously answered that, but really we want to see sort of that 50,000-foot approach of, where you see a 50,000-foot approach that aligns with the strategic questions we've outlined. Also, if I've identified any gaps. Your qualifications, I think, will be outlined more so in the biosketch. But if you have any specific capabilities that you really want to highlight, be sure to put them in that statement. And then this is a great question. How does participating in the workshop affect ability to eventually participate in the resultant funded projects? And so if you participate in the workshop, it does not eliminate you from working on the project. Sort of counter to that is participating in your workshop. The workshop is going to actually help develop the strategy and the recommended studies that will then be peer reviewed to be funded. So participating in the workshop is an important aspect of actually participating in those studies that will come out of those to be peer reviewed.
I'm going to chime in here again real quick. The reason why we're doing this in a workshop format is because we do want the investigators that are funded through this mechanism to be working collaboratively and working directly with us, so we can really address our strategic goals as a program rather than just answering basic mechanistic questions.
I think I'll add to that too, because we are an applied research program and we have limited resources, both in terms of funding and in terms of timing. As you saw, the accelerated missions that we are going to be participating in, we really do want the community to be working together collaboratively here rather than fighting against each other for funding. This is why we really want to bring the community together in this workshop and these forward groups. I feel like we should have a little bit of Jeopardy music in between when people are typing.
Do, 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 do.
That's going to be going on the internet. Jan, is there a weight of radiation quality versus more specific application for the evaluation? Jan, can you clarify, do you mean the evaluation of the proposals? Okay, thank you. That's a really good question. For this specific topic, I think it's sort of a combination of the two. It's how we address the radiation quality for the specific application of CNS or cancer or CBD, for example. How are we going to get the answers we need about radiation quality, about dose rate for those specific applications? So to me, they go hand in hand. Brock, JZ, do you have any other insight you want to provide?
I think, we want to establish models and capabilities that we can then look comprehensively at. Obviously CNS is a specific point, carcinogenesis is a specific point, and we need to factor all those in. But, some basic questions, are rodents enough? Are they good CNS models, or do we need to do something more like a mini pig, for example? Would be one question that, we could address. Jan?
Jan, did we capture that for you?
We'll say that please feel free to reach out to us at any point if you have questions that we can answer further. We have our group email that's at the end of this presentation that we can forward to the appropriate person to talk to if it comes.
Absolutely. For this RFI, there's no space flight involved, right? All the radiation exposure will be done in research labs, right? Correct. Yes, we are not looking for space flight experiments at this time, although we would love to be forward looking for those. But I think we're really going to be focusing on ground-based studies for the time being. And Holly, absolutely. Can the suggested projects leverage on existing archive samples? I think that is an outstanding idea. I think we have a lot of resources available that we would love to leverage and take advantage of. Are large animal mini pig studies allowed at the NSRL? That is a great question. So if y'all had noticed, we had put out an RFI to collect information about mini pigs. So if y'all have any information you'd like to give us on that, I would direct you to that RFI. We are working on the capability to allow larger animals, such as mini pigs at NSRL. There are some constraints on that, as you can imagine. But we do not want to limit the pie in the sky thinking. So we are working towards that, and I would like everyone to consider that a possibility for the future. Should all proposals include GCR sim studies or are purely computer simulation studies okay? I think purely computer simulation studies are definitely an aspect of this. So if you're not comfortable with doing GCR sim or some other radiation analog, I would be very happy to see what your ideas are for computer simulations, but I would also recommend tying those to how you can leverage those to either inform the experimental studies or specifically translate data from experimental studies. Anyone else on the science team have any thoughts on that one?
Say that any proposed computer simulation study has to have data to validate it and back it up.
Great point, great point. These are really great questions, y'all. All right, well, I don't see anyone typing. I'm happy to stay on for the rest of our, what is it, 25 minutes left? Ben, what's the protocol here?
You all can call it when ready. I'm going to go ahead and post the links to the RFIs in the chat.
Perfect. Thank you so much, Ben. All right, well, so what I'm going to say, oh, I see people typing again. Excellent. Like I said, I'm happy to sit here until 1 o'clock my time. So I think that's 2 o'clock Eastern time, and answer any and all questions that come through. But I think if we have about a 5-minute break of no one asking questions, we will just cut it. And if anyone has any follow-up questions, feel free to email us. All right, for low dose rate studies, should a database of low dose rate or single ions necessary to model GCR low-dose rate studies. I think I'm missing a word in here, Polly. For low-dose rate studies, should a database of low-dose rate for single ion net is necessary to model? Polly, I'm going to ask you just to clarify your question. I think I'm missing a word that's making me not understand what the question is. To Jan's point, how many people are you planning to invite for the meeting in March? That will absolutely depend on the responses that we get. We could have as few as 5, we could have as many as 30, but it really is up to us and it's at our discretion of what we feel like will be a good team to move this stuff forward. Is there a clear directive for budget limit, or is that likely to change given the current administration rejiggering that is happening? No, there is no clear directive for a budget limit at this point. That is also part of what we want to discuss in the workshop is what kind of studies really need to be done to answer these questions appropriately, and if that is feasible or not, given what we see as the budgetary future. So that's a great question, because as I think you're alluding to here, we never know what's going to be coming down the pike. So that is something that we are going to have to be a little bit nimble about, but also it's up for discussion during the workshop to understand really what is feasible and what is not feasible. And again, to that point, I think I personally do not really want to limit anyone's pie in the sky sort of ideas, but I think it's also prudent to think, okay, this is my absolute ideal study, but if I were to scale it down, what would that look like as well? So having those pie in the sky ideas, but also the sort of more down to earth feasible studies. But putting those pie in the sky ideas out there is really where we're going to maybe drive some innovation. So don't necessarily put those to bed.
One thing I do want to reemphasize is that, if you have an idea and you want to talk to us about it, please feel free to reach out. We're here to help you in addition to accomplishing our mission objectives. So, don't be afraid to reach out.
Absolutely. All right, Jeremy, can you post the link to the Inspire RFI in the chat? Yep, I think Ben is going to be doing that shortly. Polly, I think your question is getting at sort of the idea of the reference beam concept. Again, I think this is one of those questions that we need to be answering as we are developing the ideas to how to answer these questions. So if you have ideas on how to do that, and what would be the best way to leverage something like a reference beam, excellent. All right, then I would definitely say put that in there. And I realize it's 4,000 characters. It's not a lot. So succinct, clear thought on what you see as being the best way forward for something like that. But it's something I think we definitely will be discussing as we move this project forward. All right, Antonio, good luck on your lecture. All right, and Ben has posted the RFI for this specific solicitation, and it looks like he's going to be posting the other one shortly. Yep, there it is. We have the mini pigs RFI that Ben just posted. Perfect. And while we are doing that, I will grab our email as well and post that in the chat for our element email. All right, so I posted the email in the chat window as well. So at 12:40 my time, 1:40 Eastern time, I noticed that no one was typing any questions, so I will give it 2 more minutes until 12:44. So if you have any last questions, feel free to get those into the chat in the next minute or so. If not, we cut this off at 12:44, 12:45 our time. And if you have any follow-up questions, please feel free to email us at that inbox email, and any questions that we receive on this will be posted in the FAQ along with this RFI on Inspires, so everyone can see. Thank you, Jan, and thank you everyone so much for participating today. We really appreciate your participation and your interest in helping us enable spaceflight.
And as soon as the video and documentation for this presentation are live, I'll go ahead and put them out on LinkedIn and Twitter as always as well.
All right, so absolutely last call for any questions. I'm seeing lots of thank yous in the chat. Thank you all very much. So if you don't get your question in the next 10 seconds, if I don't, we'll cut it off here. Again, thanks everyone so much. Have a wonderful afternoon, and we hope to see all of your great RFIs come through our system. Don't forget the deadline is December 11th, and always feel free to reach out to us. We might not get to you within the hour, within the day, but we promise we will get back to you. If you don't hear from us within about a week, just ping us again. We won't be angry.
And just as a note, for the mini pig one, the deadline is November 27th. So if you're thinking of responding to that, it's a little bit earlier.
Thank you so much, Ben. Great, and thank you to Ben and NRES and NSpires for letting us do all this great work. So thank you, everyone. Have a great afternoon.
Everyone, thank you.